we've got two goals today. We're going to talk about graphing parabolas in a different way than what we did last semester. And we're going to look at writing equations of parabolas. So one of the goals is to be able to graph something that looks like this, where what if it's y squared? What if it's in this form? And then this is another goal, being able to do these problems, right? The standard form of an equation of a parabola with the directrix being a particular thing and the vertex being something else. And wait a second, we've never even touched this directrix word. So that's something we're going to learn about, is new properties with parabolas. We're going to go with what we already know. We already know, actually, how to graph this. We know how to use a t-chart with it. If we know the leading coefficient, we could plug in 0, plug in 1, plug in 2, plug in 3. Whenever we did parent graphs, we knew that if you were in this form, your vertex was going to be the origin. And let me graph it so you can see this axis of symmetry. We've discussed this before. Vertex at 0, 0. And if you plugged in a 1, it'd spit out a 1. It had a kind of like a U curve. And this axis of symmetry was where you could fold your paper in half. And it had a particular line. It was a vertical line through the origin. And it had the equation x equals 0. New properties that we'll be touching on, this is a definition out of your book. Any point on the parabola is equidistant from one point called the focus and a line called the directrix. This picture is in your book. It's about page 595-ish. But here's what it's talking about. This gray line that we see running up is like the axis of symmetry. It is not the x or y axis, or it's not the y axis. This is the axis of symmetry. If we have a parabola and we've got a vertex, this focus and this directrix are equally distant from every point on this parabola. So that's why you see these figures here. We knew that these little tick marks mean that, from geometry, these guys are congruent. So it's just saying that from the focus to the parabola, that point is equidistant from the focus as well as from the directrix. And then you can pick any point. So go on to the next one. It's also going to be equidistant from the focus as to the directrix. Axis of symmetry is perpendicular, that's the symbol for perpendicular, to the directrix. This is on a specific page, and I believe it's I think this is on 595. Making some notes. You got to figure out, if you see this picture, what's similar, what's different. Pinpointing what we've got. First off, we're dealing with some type of P everywhere. Notice how that's a trend. I see P everywhere. Look at what we're also going to be able to graph. We're going to be able to graph sideways parabolas, not just up and down, but we'll also be able to go left and right. When we have an up and down parabola in this first section, we're going to be dealing with x squared equals this 4py. This P that you see determines the distance that this vertex is away from the directrix and away from the focus. And whatever P is, whether it's up or down, whatever P is, that determines the focus. The directrix is always going to be the opposite of P. Notice how in every directrix you see a negative P. So every time you find the directrix, it's going to be a negative P, and we'll talk about how you find this P value. Every time you see a focus, it deals with the regular P. So something we need to get used to now is, when are you going to be up or down? When are you going to be left and right? Up and down is when you have x squared. Left and right is when we have a y squared. We're going to practice graphing. And I put up the small little notes, but really what we need to know is we are going to be up or down if x squared equals 4py, if I see something that has an x squared, and we're going to be left or right whenever I have something that's y squared. Notice how we have a y squared here. So we will have to have, we'll be ending up with a left or right equation, or a left or right parabola. The first thing we're going to have to do is figure out what is this p. This p determines everything. So to find p, we're going to set, notice how in this equation, you've got 4p. Let me blow this up. In standard equation, we have this 4px. This position should be equal to 2. So here's what I'm going to do. 4p is going to equal, should be the same value as 2 and solve. That'll determine my p-value. I divide both sides by 4, and I get a p-value of 1/2. This is how far away your focus is and how far away your directrix is from your vertex. Since p is 1/2, I'm going to plot a point for the focus. I'm going to label it F. Directrix will be half away on this side. I need a spot to indicate -1, and I'll put in a dashed line at x equals 1/2. Ooh, my bad. It's a dashed line at x equals -1/2. Let's talk about how you finish that parabola. The parabola always surrounds the focus. I'm not going to be picky about this, just as long as you make your parabola curving towards the focus. It's kind of why it's got its name. It's the focal point of the parabola. Looking at that page, I determine which equation does it look like, and we've got an x squared, so I'm either going to be up or down. So I'm going to set -8 equal to, my bad, I'm going to set 4p equal to -8 and solve for p. The focus is -2 away from the vertex. Put a point and indicate that it's the focus. We're also going to go the opposite direction from the vertex and show where the directrix is. The directrix is going to be 2 spots away on the y-axis going in the opposite direction. So at +2, we should have a dashed line, and that dashed line has an equation of y equals 2. The last step is to fill in your parabola. Your parabola goes around your focus point. First, I'm going to draw a sketch. I'm going to draw a sketch of where this focus is and put an F. So if it's at -3, 0, I sketch it, put an F. The vertex is at the origin. If I were to draw a quick parabola, I know the parabola has to go around that focus. I determine how far that focus is away from the vertex. How far away is it? So if I move left 3 from the vertex, the p-value is -3. Notice how I move left. So I'm going to need one of these equations to use. This is what I'm going to model from. This y squared equals 4px. If I know p is -3, my equation is just -12x. Next equation, or next example, I'm trying to write an equation. What if we were given the directrix? If the directrix was y equals 4 and the vertex is at the origin. First thing we're going to do is draw a sketch to try to map out what we've got. We've got a vertex at the origin. We've got a directrix at y equals 4. That's a horizontal line at 4. Now the vertex does not surround the directrix. So what's hard about this is I need to find the focus. And the focus is on the opposite, the exact opposite on this axis, 4 spots away from the vertex. So the focus is at 0, -4. That's going to be key. Finding the distance or the direction from the vertex to the focus is my P. My P value is going to be -4. I use the up and down model using this x squared equals 4py. Plugging in the P value that I just found. And simplifying. So this last one, if I have y squared equals 4px and the P value comes from how far and what direction the focus is from the vertex. Since the focus is -6 from the vertex, I'm going to have -6 as my P. Y squared, whoa. Y squared equals -6. No, -24x.